Hello guys, I just want to make a little video to help you review for the test that's tomorrow. These problems are going to seem pretty familiar. Some of them are just little minor tweaks. Some of them are stolen off of the test review or the quiz review. But I hope that it helps you feel a little bit more confident going into the test tomorrow. You hopefully have already seen your quiz from yesterday, and you hopefully are looking at that. The quiz and the test are not going to be that much different. So if you can take that quiz grade that you have and pick up a few things from today's review and just improve that score, you're going to do fine on the test. So let's look through some of these together. Okay, so h of 12. I'm looking right here at x plus 5. So we're going to plug that in. So instead of x, we're going to put 12, and then you're just adding them. 12 plus 5, 17, done. K of 3, I have this longer equation, so we're going to say 3 times 3 squared plus 3 minus 2. Okay, so I put 3's in wherever the x's were. I saw some people make mistakes on this on their quiz. When you do this part, you have to do the exponent part first. Okay, so 3 squared is 9. So this becomes 3 times 9 plus 3 minus 2. 3 times 9 is 27. Plus 3 would make 30. Minus 2 would be 28. Okay, so if any of these are going too fast for you, just pause the video, back it up, think, write it on your paper, work it out, slow it down a little bit, okay? Anytime, so I'm looking at number 3 now, anytime you have x's in there instead of numbers, it means that you're just going to push things together and combine like terms. So if I have 4x minus 3 and x plus 5, and they're being added, I'm just going to combine those. Don't make it complicated. There's not, the answer is going to look weird. You're going to have 4x and 1x makes 5x. You're going to have negative 3 plus 5 to get positive 2. Okay, so then similar to that, this next one has subtraction happening. So h of x is x plus 5 minus, now put parentheses around this because we're subtracting whatever g of x is. So 3x plus 4 is being subtracted. So I have x plus 5 minus 3x minus 4. X minus 3x is negative 2x, and then 5 minus 4 is positive 1. We're just combining like terms again. Okay, so number 5 is a little bit different because there are numbers plugged in for x now. Okay, so let's get some space here. If I do m of 1, that part's not that scary. We do 3 parentheses 1 squared plus 8. 1 squared is 1 times 3 is 3. 3 plus 8 is 11. Okay, so that's kind of our first answer. Then g of 4 means that I'm going to take function g and plug 4 in for x. 3 times 4 is 12. 12 plus 4 is 16. So that's my second answer, but I'm going to subtract those two. So I'm really just doing 11 minus 16. 11 minus 16 is negative 5. Okay, last one. 3 goes into function f first. Okay, do this inside part first. So 3 goes into function f. That means 4 times 3 minus 3. 12 minus 3 is 9. So that's what goes into function m. Okay, 9 is my answer. Now I plug it into m. M is 3 times something squared plus 8. The something is a 9. So we're going to get a big number here. So 9 squared, remember, do the exponent first. That's 81. 81 times 3 is 243. Add 8 to that, you get what? 251. Okay, we can do these. Just keep working on them. Okay, practice them a little bit more. All right, so moving on. Number 7 says determine whether the following mapping diagram represents a function or not. We've seen this one before. We know it's not a function. Why is it not a function? Because there's two, the 5 here goes to two different things. So a number in the domain or the input maps to two outputs would be a good way to say that. Number 8, which of the following sets of ordered pairs does represent a function? Well, looking at the first one looks good to me. The second one does not work because -2 goes to -3, but it also goes to 4, so that one's out. The third one, -7 goes to -2, -7 goes to -9, so that one's out. The fourth one, -8 goes to 5, but it also goes to 8. That one's out. So it's gotta be this first one that's okay. So circle the first one and say each x goes to one specific y. Okay, something like that. Because the reason these other ones don't work is because, the x, -2, sometimes it goes to -3, sometimes it goes to 4. Okay, let's see. So I can go to the next page. All right, so determine if this graph represents a function. Why or why not? Well, vertical line test, right? If I draw a vertical line through this graph, it's going to hit the graph twice. So not a function. And then the part we had trouble with on the quiz was the explanation. Let's say something like a vertical line crosses the graph at 2 points. Okay? All right, 2 more. Number 10, your family goes on a vacation. They're 500 miles away. You assume you can average 65 miles per hour. So first of all, filling out this table, I'm going to put 500 as my starting point. And then I kind of know that my equation is going to have a y-intercept of 500 as well. If we're getting 65 miles per hour, or 65 miles per hour is our speed, then we're going to get closer to our destination each hour. So 1 hour after 500, or 1 hour after we start, we started at 500 miles away. 65 miles later, we're going to be 435 miles from our destination. Another hour, I'm just subtracting 65 each time. And then another hour gets me to 305 miles away. So what's happening each hour? H is my variable with my change. Every hour, we're gaining 65 miles. And so what's happening is it's getting 65 miles smaller. We're getting closer, so we need it to be negative. All right, last one. Domain and range. So we're looking at how far left and how far right we go. What is all the x values that we can have? So it looks like -9 and +10. The 10 has a filled in circle, so that's going to be a bracket, but the -9 needs to be a parenthesis. Then moving the other direction, how low does it go? How high does it go in terms of what y values now? Okay, so this looks like 2 and what is that, 7? And it's not super clear whether we're getting to these points, but I'm going to say that we are, and so I would put brackets on it. Maybe. There we go. Okay.